There are a bunch of emails here. How can we fill out these span without knowing? Today we will introduce a class of methods, clustering. Roughly speaking, it is divided the mail into multiple categories in a certain way, and we mark the normal mail category, mark a small amount of spam, and the remaining unknown messages in this category are also highly likely to be spam. There are several categories of clustering methods. The first is density-based methods, where the internal density of clusters is high and the density between clusters is low. The advantage of this method is that the shape of the clusters can be arbitrary, even such. Second, hierarchical-based methods is constructed into a tree-like hierarchy. Third, partitioning methods divide all samples into different categories. The k-means algorithm described in detail below falls into this category. This is the specific steps of the classic k-means algorithm. Let's take an example. These nodes represent different samples. We need to manually set the number of clusters k first. Obviously, 3 is the most suitable here. Then, k clusters need to be initialized. That is 3 cluster centers mk. Next, we start the loop iteration. The number of iterations needs to be set in advance. For example, 1000 here. Then go to each iteration. For each node, such as this. First, the first one measures the distance between the node and each cluster center. Find the nearest node. Put yourself in this set of clusters. We use the same color to mark. Then, each of the remaining nodes is similar and placed in the corresponding set. Now, with a new collection CK for each cluster, the nodes in the collection are averaged as the new value of each cluster center. Okay, let's start the second iteration. Each node remeasures the distance. Attach the corresponding color to each node according to the shortest length. Then update the center position of each cluster. Then we started the third iteration. Each node finds the nearest cluster center again and becomes the corresponding category. Then update the center of each cluster. Okay, it looks almost done. In fact, the actual data will be very complex and may require more iterations. In summary, the k-means algorithm can be divided into two parts. One is to find the nearest cluster center for the sample. Become member of the cluster. The second is to average all the samples in the cluster collection to get a new cluster center. Alright, this video is over here. See you in the next issue.